Bing bong, bing bong.
Thanks, Kaden. Okay, 2.5, modeling direct variation, okay? This is going to be just memorizing the formula. Okay, remember how we talked about inputs and outputs? And when we input something into X, we get an output of Y, yeah? And the input is, what's the term? I'm trying to think of it. The output is what's relied upon the input. So the output varies depending on my input, correct? Okay, so we're going to take that and we're going to do direct variation. Meaning when I plug something in, it directly varies something else. Simple enough. So direct variation, the equation y equals a times x, okay, represents direct variation between x and y. And y is said to vary directly with x. The non-zero constant a, so a has to be a number, it cannot be zero. Okay? The non-zero constant a is called the constant of variation. So it tells me how it's affecting y. Okay, it's the constant of variation. The graph of a direct variation equation y equals ax is a line with a slope of a and a y-intercept of 0. So slope of a, y-intercept of 0 would be here, and my slope would be whatever a is. In this case, my slope is 1/2, so it's going like this. In this case, my slope is -1, so it falls that way. Okay? Write and graph a direct variation equation that has -4/8 as a solution. Okay, -4/8 as a solution. What do you think that means when it says write and graph a direct variation equation that has -4/8 as a solution? What is the direct variation equation in general? Y equals ax. So let's start there. So if we have y equals ax, okay, and I know -4/8 is a solution, do I have an x and a y?
Yes.
You okay? So what do you think I need to do with that x and y that I'm given?
Plug it in.
Plug it in so that I can solve for a and then I can rewrite my equation. Okay, so x, y, I'm gonna plug it in. So 8 equals a times -4. How do I solve for a? Yeah, I'm gonna put parentheses around here so we can tell. And a equals what? What's 8 divided by -4? -2. Now I can create my equation because I have an a. My equation is y equals -2x. There's my equation of direct variation. Yes, a is my slope. You are 100% correct. Do I have a y-intercept on this? So where does my graph always start? At 0, 0. So do I even need to plug numbers into this right now? No, I'm gonna go to 0, 0. I'm gonna put a point. And then my slope is what? -2, which some of you missed this on your test yesterday. If my slope is -2, I'm going down 2 over 1. Down 2 over 1. Down 2 over 1. I am not having a line that goes up like that. My line falls. Okay? So here's my direct variation and the graph. Does that seem simple enough? So direct variation is still a linear equation, just your intercept, your b, is what? What is my b on these? 0, yeah. My b is 0, and then I basically have a slope, that's all. Okay? It's pretty straightforward, pretty simple, okay? Now, we get word problems with it. Let me see if I can just shift this over a little bit. Okay. Hailstones form when strong updrafts support ice particles high in clouds, okay? Where water droplets freeze onto the particles. The diagram shows a hailstone at 2 different times during its formation. One is at t equals 12 minutes, it's 0.75 in diameter, and one is at t equals 20 minutes, and we don't know its diameter, okay? Write an equation that gives the hailstone's diameter in inches after t minutes if you assume the diameter varies directly with the time the hailstone takes to form. How can I do part A? How can I create an equation? First, we gotta decide what's varying upon the other, okay? The diameter is varying upon what? Yeah, the time. So instead of saying y equals ax, I'm gonna say d equals a t, okay? So we want an equation that says d equals a t. Do you guys understand where we got that information from? Okay? The diameter varies according to time, so d equals a t. Oh, that looks too slow. Okay, so now I have to create an equation. Can I create an equation to solve for a in this case? Do I have enough information somewhere? Where? The bottom one. I have a d and I have a t. So I'm going to use the d and the t to solve part A, okay? So part A, my d is 0.75, yes? Times A times 12. To solve for A, I simply divide 0.75 by 12 and A equals what? Thank you, Kaden. 0.065. 0.065, is that what you said? 625, okay. 0.0625. So my equation should say the diameter equals 0.0625 times t. That's part A. Does that make sense? Okay, any questions thus far? We good, we good? You guys are so quiet, I never know. Okay. Part B says, using your equation from part A, predict the diameter of the hailstone after 20 minutes. What do I have to do? Plug in 20 for t. So part B, I'm going to simply say d equals 0.0625 times 20. What is that? 1.25 inches, right? Is that what it is? It's in inches, correct? Yes, 1.25 inches. Don't forget to put units with what you're doing. Not too difficult, not too difficult. So the size of the hailstone depended upon the time that the hailstone took to form. Makes sense, right? Gonna get bigger hailstones, the longer it takes to form them. Okay. And then the last section of this. So direct variation we can rewrite in ratio form, okay? What I mean by that is this. Because the direct variation equation is y equals a times x, okay? You can divide y by x to get what a is, correct? And a is simply a ratio. Whether it comes out as a whole number or comes out as a fraction, it's still a ratio because it would be like 3/1 or 1/12 or whatever. My constant is always a ratio. Does that make sense? Okay. So sometimes they just want us to come up with ratios of things to show what the constant would be. Okay. So on this problem, it says great white sharks have triangular teeth. The table below gives the length of a side of a tooth and the body length for each of the 6 great white sharks. Tell whether tooth length and body length show direct variation. If so, write an equation that relates the quantities. So here's the deal. If we set up proportions, okay, into this y over x form, and if all those proportions are the same, or very, very close, because we're dealing with a shark right now, okay? If they're very, very close or the same, then that means I can create a direct variation equation, okay? If one of the proportions is off compared to the others, like if all of them are 1/2, 1/2, 1/2, 2/3, then it does not have a direct variation equation, okay? It's not showing a linear pattern is what it's not doing. Does that make sense? Okay? Ratios have to be the same. Just like in geometry last year when we talked about two shapes are similar if their ratios are the same. Same concept. Okay? So here, we've gotta decide what's my X and what's my Y. Is tooth length my X or is body length my X? Which one would you think? Well, think about this. When you grow, okay, as a child, okay, you only switch teeth like once, right? Like you, okay. So, do your teeth grow depending on your height, or does your height grow depending on your teeth? So you mean I can't grow taller until my teeth fall out? Or I get my second set? No. So your body grows, but, and then your teeth grow.
Yes.
So it's body over teeth. So for sharks, it's gonna be body over teeth. Also, it says, tell whether tooth length and body length show direct variation, okay? And it says the body length, it says the table below gives the length, it just tells us what it gives. But I would do body over tooth, like Y over X, right? Y over X, body over tooth, so that you can set it up. So if I do all of these proportions, I'm gonna have 215 over 1.8. I'm gonna have 290 over 2.4. 350 over 2.9, yeah? 430 over 3.6. 565 over 4.7, and 695 over 5.8. Now, tell me if those proportions come out to be about the same. Other people can't participate besides Al. You are going to have to start bringing a calculator to my class, sir. Divided by 1.8, what did you guys get? Okay, 119.4. Okay, what is 290 divided by 2.4? Okay, 120.8. 350 divided by 2.9. 0.7, okay. What about 430 divided by 3.6? 119.4. And what about 565 divided by 4.7? And 695 divided by 5.8?
119.8.
Good. Okay. Do you think we could create a direct variation equation off of this? Do the proportions seem close? Yes, because we're dealing with a shark and growth rates. So those are like all within one number of each other, correct? Okay, now if we were dealing with something that's like precise, then it needs to be exact. But this is a shark length and body length, so that's close enough for me, okay? So we can create an equation off of this. How do you think we're gonna create an equation off of this? Okay, if this is B and this was T, right, and we did B over T here equals A, okay? A equals B over T, that means my equation should say B equals A times T, yes? Okay, what is my B in this case? Do we know?
Yeah, the body length.
My body length, but I don't have like a set body length, right? Okay, so I have B equals, what is my A in this case? What do you wanna choose? Let me tell you something, make it easy on yourself and just round it to a whole number. So what is all this like pretty close to? 120, let's make it 120. There's my equation. Okay, there's my equation. Body length equals 120, which is my constant variation, times the tooth length. Cool? Okay? That's what you're working on tonight. Direct variation, y equals a times x. same type of concept where they're gonna give you things and you just have to plug it in, solve. Don't forget that when it says create an equation of this, that you have to recreate your equation to say y equals whatever your a was times x. Don't stop short.